All right, hello and welcome. As you said, I'm Mike Solomon, and I work on the Strato team at Twitter. You can follow me. I'm at msol on Twitter. And today we're going to talk about Twitter's virtual database powered by microservices, and we call that Strato. All right, so a microservices powered virtual database sounds pretty fancy, and you're right, it is. But it's really hard to understand why it works the way it does unless you see an example of how you use it. It's not like how you use MySQL or Postgres or some other database like that. So we're going to look at it from a bit of a strange angle for talking about a database. We're going to build a product feature. So as an example, we're going to build the tweet off feature. I promise I'll tell you what I mean by that very soon. But first, we're going to build this feature in a microservices environment. At Twitter, we have lots of microservices, hundreds of services, and we need to talk to all of them, and you run into particular challenges. So we'll walk through what building a feature looks like and the challenges you run into along the way. Then we're going to do a really quick introduction to Strato, because that's probably why you're actually here. And then we'll actually go through that same process again, building the same feature, but this time on top of Strato. And that way we can contrast. All right. So our story begins, like very few stories begin, with a tweet off. So let's talk about this tweet off feature. You can see here that we have 3 tweets of varying quality. And we have a simple task. We want to determine which of these tweets is the best. In data terms, we basically want to implement this function. We have a set of tweet IDs, and we want to return the tweet ID that corresponds to the best tweet. So that's pretty straightforward. And if you've had time to read these tweets really quick, I hope you agree that this tweet is the best. I think it's basically just a fact. All right, so let's get to work. Let's build this thing. We're working in microservices, so the first thing is let's start a new service. So this usually follows a few standard steps. First one, let's start a brand new empty service. This pretty much always entails some service code boilerplate. So you're going to have to set up your main, some build files, some dependency configuration, that sort of thing. Then we get to move on to even more fun, configuration boilerplate. We need to set up our deploys, we need to set up monitoring, dashboards, paging alerts, that sort of thing. There's a lot to do there as well. And we also probably need some operational documentation. We're going to need to document the processes and failure modes in a run book or something like that. So already, we've kind of run into some problems. So let's list these difficulties that we've run into so far, and later we can go back and see if there's anything that we want to address. So already we can kind of see that starting a new service is hard. There's a lot of work involved, and it would be nice if maybe there was some way we could avoid doing it. It's kind of a problem. And once we've built a service, it's probably obvious that we have to operate this service more or less forever. If we want to keep this feature around, we need the service that powers it, and there's kind of no getting around that. So let's kind of draw what we have. Now we have the tweet off service. Trying to build this tweet off feature, spun up a new service. This is what we have, and it contains no business logic whatsoever. And of course, we still have our list of problems. All right, so let's come up with a plan for how we're going to do the rest of this. So we'll also keep this list of problems around so that we don't lose track as we go. And we can keep adding stuff to it. So let's make what we're building concrete. We want to return the best tweets, or the best tweet out of those that we have. And there are probably already some services that exist to score these tweets. So we're not trying to build a machine learning model to tell you which tweet is the funniest or the most impactful or whatever. Let's assume that those already exist. We're just trying to build the service that chooses the best tweet. So let's assume that these other services exist. We're then going to need to call those services because we need the data that they provide. And then we're going to need some business logic. So let's just sum up the scores that they return, kind of assume that there's some services that score a tweet based on some dimension. We're going to add those up, and then we can return the tweet with the best score. Seems pretty straightforward. OK, so let's actually start implementing this thing inside our empty service shell. So let's go off and do that. So first, we need to figure out who to talk to. And by that, I mean which services to talk to. So that's not always straightforward when we have hundreds or even thousands of different services. So let's write that down as another problem that we might have. This is definitely true at Twitter. You're not always sure which data source is the right data source, and it can be hard. It can be hard to know. Maybe let's just say we ask somebody and they happen to know. So that's what we do here. We probably want to talk to the tweet rating services, assuming they exist. So let's draw this out again. We have our tweet off service, no business logic inside of it. And we have maybe a couple of different services that score tweets. We'll call them the isTweetFunny service and the isTweetInsightful service. And the next thing we need to do, now that we know about these services, we'll keep this picture around. Now that we know what we want to talk to, we need to know how to talk to them. And that means figuring out their service interface. So this can be JSON or Thrift or protocol buffers, but there's always some kind of schema, even if you never write it down or document it. In practice, you'll usually run into quite a few inconsistencies here. So even with typed interfaces, we've found that many services support batching or multi-get, has different names, and all services expose errors in some way, and we found that these things in particular often differ from service to service. So that's kind of a problem, so let's write that down as well. Okay, let's assume that we've sorted that out, we figured out the service interfaces, and now we can actually communicate with these services. Now it's finally time to do what we set out to do, which is implement some business logic. Okay, so it might look a little something like this in pseudo-Scala. We already kind of talked about this. We're going to map over our tweets. For each one, we call out to some other service to get the funny score and the insightful score. We'll add them up, and then we'll pick the one with the highest score, and then we'll return that ID. So this is also another problem. We had to implement some business logic. So we'll write that down like all of our other ones. And it's time to light up our service. We're pretty much done, right? Almost. There's a piece we forgot still. But we are in the home stretch. So we actually need to define this service interface. So we have lots of different choices here. We could use protocol buffers or Thrift. We could use JSON or XML, or at least 10 others. We have tons of choices here. So this is also a problem. So we'll write that down. And at least at Twitter, we often encounter another problem. We found that once we pick a protocol, we usually pick Thrift. Somebody always wants it in some other protocol, usually REST with JSON, and sometimes GraphQL, sometimes something else. So we might have to support other protocols as well. So let's write that down, supporting other protocols. OK, we're done. We successfully built the tweet-off service in a microservices world, and we accumulated a list of problems along the way. Great. So after all that, we have this again. This is what we were building. We picked the best tweet, and what we set out to do was show that my tweets are not the best tweets. And it wasn't easy getting here, and we ran into lots of problems along the way. All right, let's finally talk about Strato. As I said before, Strato is a virtual database that's powered by other microservices. So let's talk about how Strato models the world. Like most databases, Strato has a centralized catalog of data. Usually this is per database, but here we have a virtual database. So in principle, it kind of encompasses all available data. But in order to make that true, we actually need to expose data via Strato. So we also have a library of configurable adapters for existing services, and also for existing databases. And these kind of translate into tables in our virtual database. So Strato can talk to existing services and existing databases. OK, so now we have a central catalog of data that has type and schema information about the data that's available, also the location of that data so that it can contact it, what protocol it speaks so that it can actually talk to it. And that's not a bad start, but it's also not really a database. So let's add a query language. We don't really have time to get into details here, but we have our own query language that looks kind of like Scala. Let's just pretend it is Scala, but basically it's designed to make it very easy to compose, filter, and join data together. And the main reason that we have this query language is so that we can create query-defined data sets. So some databases call these views, others call them stored procedures. And in Strato's case, this is how you combine, filter, and modify other data sets. So the data can come from anywhere else in Strato. It can come from other query-defined data sets. It can come from data sets that are powered by existing services, by databases that have been adapted to Strato. It can come from anywhere. So now in this picture, we can see that Strato lets you get data from query-defined data sets, as well as data sets that are actually powered by existing services and databases. And this is great. But we are still missing one piece, a very important piece: clients. So by clients, I might mean other services that need to read or write data via Strato, or even end clients like apps on mobile devices. And some of you might see an issue here. Some clients, like servers, might want, say, a nicely typed Thrift API, but mobile clients might want a REST API with JSON or a GraphQL API or something like that. So because Strato knows the type definition of your data, we're actually able to generate Thrift, REST, and GraphQL APIs automatically. So that means that your clients get to choose their API protocol. And that is a really quick introduction to Strato. So I know I went through that really fast, but we're trying to build a feature here, and that means we have deadlines, so we have to keep moving. So let's get started building our feature again. This time around, we have Strato. All right, let's start a new empty service. We've got our list of problems here. Let's get this started. But wait, hold on. We don't actually need to do that. We don't need to start a new empty service. And why don't we need to do that? Because of query-defined data sets. Instead of building a service, we actually just need to write a query that will get hosted by Strato. So that means right off the bat, we can cross off our first problem. Starting a new service won't be hard because we're not starting a new service. And obviously, since the service won't exist, we won't have to operate it either, so we can cross that one off too. I realize these claims might sound a little unfounded so far, so let's make this more concrete. Remember that Strato has a centralized catalog of data. This tells us the types of the data and where it is, all behind a uniform interface. And also remember that lots of data sets are already exposed through Strato. So here, we're trying to write a query because instead of exposing raw data, like the machine learning model's score of how funny a tweet is, we want to pick the best tweet. So in other words, we want to expose a new synthetic data set. Once we do that, it'll appear as a new data set in the Strato catalog, and it'll be just as easy to access as every other data set. OK, so step one is to find the data sets to talk to. But hey, guess what? They're actually easy to find and read about now because they're in a centralized data catalog. So let's cross that out, because even though it's still a problem, it's now a pretty easy one to solve. The next problem is we're going to need to actually call these services. And remember, this was hard before because batching, error handling, and other inconsistencies meant that we had to learn each service's interface. But in Strato, interfaces are simply the data types. Batching is handled for you, and errors are always exposed the same way. So we no longer have to figure out inconsistent interfaces. The next step, we need to implement some business logic. This part actually stays the same. I mean, I don't know what you want from me. It's not an AI conference. We haven't built general AI. You're still going to have to write your business logic. Sorry. OK, let's bring it back to the tweet-off service, or the tweet-off feature, rather, that we're trying to build. So we actually need to write the query so that Strato can host it. And it's going to look a lot like before. So let's bring that business logic back. Just remember that a lot of the batching and other things are handled for us. This isn't really reflected in the code here, but that can also be a big deal. All right, so we have our logic, and this talks to some services that are exposed uniformly through Strato, and now our picture looks like this. Hopefully not too surprising. OK, next step, the time to define a service interface. So if you recall, in Strato, all you need to do this is a type. So you're probably used to doing this in Thrift or with some kind of JSON or with protocol buffers. But we actually don't need any of that. We just need the type. And here, as we said before, this is basically just a function signature. So given a set of tweet IDs, we're going to return the tweet ID of the best one. And that's pretty much what we need. We don't need to do any more work than that to define a service interface. All right, so let's look at this as a diagram again, maybe make it a little easier to follow. So we have Strato, and we have some clients. And we also have an interface between them. And this interface is defined by types. OK, let's keep that around. The last piece we need to do is support some protocols. And we actually want to support multiple protocols for reasons that we talked about before. And in Strato, this is pretty easy. How is it easy? Well, we can actually derive the APIs from the types. So we have the type information about every data set. This does mean there are no custom APIs. Your API will predictably match your data always, because you don't get to make any choices about its shape. You can change its shape, and that will, of course, be reflected. But this means that data access is always very predictable. So in practice, in Strato, we basically support 3 protocols: Thrift, REST/JSON, and GraphQL. So now our picture is complete, and clients can choose to talk to Strato over their preferred protocol. Cool. Let's see. Once again, we've built what we wanted. And this time, it was much easier, even though my tweets still aren't the best. OK, so here's the list of problems we've accumulated. Let's pretend we're in Minority Report, rearrange things a little bit. And we can maybe look at them like this. So here are the problems we encountered when building our tweet-offs feature in a microservices environment. And here are the problems that we have in common when building it in a Strato environment. So let's look at those side by side. As you can see, a virtual database like Strato does not do all of your work for you. But it does let you focus on the things you cared about in the first place. You get to focus on implementing your business logic and defining your interface, in this case through a simple type definition. That means we eliminated quite a few steps. We don't need to start a new service. We don't need to operate that service. We don't need to do as much work to figure out which services to talk to. We don't need to figure out inconsistent interfaces, because they're predictably generated from types, and batching is handled for you, and errors are always handled uniformly. And we don't need to support multiple protocols, because once we expose type data, it generates APIs automatically based on those types. And that leaves us with the part that really only people can do currently, which is implement business logic and defining what we actually want the interface to look like by choosing types. So I hope today that I've convinced you of this. A uniform virtual database lets you focus on your problem. If I had more time, I would tell you a lot more about how Strato lets us trivially apply things like caching and event logging, and also apply a simple access control model. There are tons more features that Strato brings, and you might be able to imagine some of these. You can really leverage these uniform interfaces and the power of the types that you have to choose. Unfortunately, I don't have that much more time, so I won't. Thanks for listening. Again, I'm Mike Solomon. You can follow me if you like bad tweets. I'm msol on Twitter. And if you want to try this stuff out for real and see how it works in detail, you can come work at Twitter. Thanks.
So we do have time for 2 questions if anyone wants to ask anything.
So you can create these virtual data sets, which are projections of other services, but you don't know how many times that's happened, right? The interface is consistent. So is the performance kind of unpredictable, because you could be calling a service that's calling a service that's calling a service any number of times without knowing how many RPCs your single interface is actually going to result in?
Right. The number of RPCs that are made is totally hidden from you. you'll probably see it in your latency if that's like very tight. Then you can obviously go behind the scenes, figure out what's calling what, and optimize from there. Another option that's very common is it's very easy in Strato to layer caching on top of things, and all the logic is already implemented for you. You basically say, take the synthetic data set and cache these results. You can do read through and write through caching.
Is that about an interface when I expose a service? Can I say what the memorization policy is? So people who are calling it know when it'll be cached and when it expires.
Yeah, when you define a query-defined data set, part of that configuration, you can basically just wrap it in caching. That doesn't get exposed through the service interface. It looks totally uniform to your clients. They don't know that it's being cached, but it is behind the scenes.
So having a global picture of all the services running, I'm guessing you can do a lot of the global optimizations. I don't know if you guys currently do that, and if so, can you go into detail?
Yeah, that is something we would like to do in the future. Right now, we've been so busy building the thing that we haven't had time to do that yet. But yeah, there are some things I think we'd like to do in the future. One thing that has been nice is because it transparently supports batching, we have been able to get pretty good performance overall. Anyone else?
So it seems like this model is very useful and can be applied to almost every problem I can think of. And it solves every one of my concerns. Is there something this cannot do, and something you would not recommend using Strato for?
Things I wouldn't recommend using Strato for. Yeah, definitely. So right now, this isn't totally baked into the model, and we hope to sort of maybe like expand this in the future. But right now, a lot of it is fairly key value oriented. So there are some use cases where imagine you have like low traffic, and what's really important for you is like flexibility. You might be better off talking to a traditional database like MySQL or something. It can be tricky to add like new indexes and that sort of thing in many cases. Yeah.
Thanks, great talk. So I might have missed a bit about GraphQL. What makes GraphQL such a great kind of interesting thing? Is this something growing at Twitter? Can you talk about the future of GraphQL as you see it at Twitter?
Sure. So GraphQL in general, probably not everyone's familiar, but it's a query language that came out of Facebook that is very product oriented, makes it very easy for people building client apps to select the data that they need. So the way Strato kind of works with that is we're actually able to generate a GraphQL API from that, which means that people adding new data are able to expose it very easily. It shows up very predictably for clients, and people building apps and so forth are able to select that data without very much further interaction with the backend. There's no need to add custom endpoints to expose new data, for example. Does that answer your question? Cool.
All right, thanks everyone.
Thanks.